Saxon Algebra 1, Lesson 36, we're going to take the distributive property and we're going to amp it up to a new level. Sorry, my book just bumped my light. Let me show you what it looks like, and then you'll see the challenge before us. Use the distributive property to expand. What did I just do to us? I put fractions in. Okay. All right, you finish copying while I double check for mistakes. Oh, this is a y, not an x. 3y cubed over m. Okay, good. All right, I don't think we have distributed fractions yet, so let me tell you how it works. We take the numerator and distribute that, and then we take the denominator and we distribute that. It is more steps, but it's not any harder, all right? Remember that when we are multiplying matching bases with exponents, we can add the exponents together. So when I go to multiply x squared times x squared, I know, okay, the answer is going to be x. 2 plus 2 is 4, right? Then I'm going to have a minus sign. And then this, there's no basis to combine, so I just write the whole thing out. 3, I go alphabetical, like so. Now I've done the numerators. Now let's do the denominators. This is an invisible 1, so that's 2 plus 1 is y to the third. And there, I've already got the minus sign, and then that would be my squared. Double checking my answer, x to the fourth over y to the third. Oh, and then as our last step, this is all correct. As our last step, we see in here, we've got the quotient rule going on. Because if we have the same base above and below, like see the y, we can subtract. 3 minus 2 will give us 1. So we can rewrite this as x to the fourth over y to the third. That's the same. Minus, okay, the 3 stays the same. The x squared stays the same. But this cancels to give me just a y, and then the whole thing is over m. So this is our final answer, right? In this example, I distributed both numerators and then I distributed both denominators. That's one option. The other way would be to do top then bottom of the first fraction and then top then bottom of the second fraction. I recommend that you try it both ways and see which way you like better. It's personal preference. You'll get the same answer. 36.2. And I think I mix it up. I do it different ways, different times, just depending on, you know, my mood. Next one, m over z. Again, I much prefer to go alphabetical on these. Life is so much easier when things are in order. Okay, this one looks weird, doesn't it? Because we have fraction, fraction, not a fraction. So I like everyone to be in the fraction club. It makes life much easier if we get everything looking good from the beginning. All right, same strategy. We're going to distribute the denominators and the numerators. We don't have to do anything up and down. Last time I did both parts of the numerator and then both parts of the denominator. This time I'll do top and bottom of the first one and then top and bottom of the second one, just to show you that it works both ways. Okay, so this will become AMPX over KMZ. I see I've got some matching letters in there. I'm not going to simplify yet. I'm just going to do all my multiplications. This minus sign carries. And then now, look at, there's a matching base. So I'm going to add that. It will be 2m to the 5th, right? P to the 4th. And then on the bottom, it'll just be z. Now, I go back and look to see, is there anything I can cancel? And I see these m's here. And I know those are going to cancel out. I can think of it as m to the 1 minus 1. Or sometimes it just helps people to see that you can just cancel if it's on the top and bottom. We've been doing that for a long time too. The important thing that I want you to notice is that within this term, everything's being multiplied. So we can go ahead and cancel quite easily. So my final answer will be APX over KZ minus 2M5P4. Make sense? Beautiful. That's correct. This is correct too. I have been falling down on the job with my smiley faces, haven't I? It's just really shameful. Okay. One more. I'm going to squeeze it in here. Ready? This one is it's got 3 parts inside the quantity. It doesn't matter. This one it doesn't have a denominator, but I'm going to give it one as I copy it down. I don't want anything floating. That's just weird. Minus 4 over c squared. Okay, so let me just show you so you're 100% clear. Look up. In the original expression, see how the 2bx is floating in the middle? It's not a fraction. I don't like that. I want it to be in the fraction club. So I gave it a denominator of 1. All right, this works exactly the same as we've done before. We're just going to distribute. I'm going to do numerators and then denominators this time. So here we go. I will have 2a's, 2b's, 1x. Oh, I just want to do the bottoms this time. C to the 3rd. Can't resist it. Now I'll do the middle term. I've got a number. That's fun. No more a's. 2b's now. And an x. And on the bottom, I'm multiplying by 1. So just that c squared. It helps so much just to have that 1 there to remind you there's no other denominator. Just fire away times 1. And then minus the numbers we usually put first, right? And then a and b over C4. C4 is plastic explosives, right? I've watched my detective shows. I'm trying to think of what's the name of the one that the guy who played Jim in The Office was in. He was like a nerdy numbers dude, and then he got sent out to the field. John something. It was on Netflix. I don't know if you've seen it. Anyway, I'll find out and tell you what I'm talking about. All right, and then we just look and see if there's anything we can simplify. And I don't see any letters that match within each one. Notice we can't cancel across, right? We can't go like this because we're adding and subtracting. We could cancel within each fraction, but there's nothing to work with. So I'm just going to double check my answer. A squared b squared x over c cubed. Okay, that's the right answer. Yay! So that is how we distribute when we have fractions. Now, the last thing that I want to talk to you about, there really isn't a problem to do this. To do with this, I'll make one up for you. But what we want to talk about is the difference between minus signs versus negative exponents. And an example of this would be that. This expression that we're supposed to simplify has the same looking thing right there, right? In two places. It looks exactly the same. It's a minus sign, right? But no, it's not. This is a proper minus sign. This is not really a minus sign. It's a negative exponent. This is a trapeze. This is not a trapeze. All right? They behave completely differently. Negatives in exponents are a sign that says flip it. Take the reciprocal if it's a mathy-brained minus sign. But this isn't a minus sign like this is. This is a trapeze. So we change this immediately into 1 over minus 4 quantity squared. Notice that when I move from here to here, everything is the same except I put 1 over, right? I take the reciprocal and I burn off that minus sign. It's gone now. So in the flipping, the trapeze is used up. That's completely different from how we deal with this one. So it's very important that you make this distinction, and it's a very easy thing to get confused about. Now that we've burned off our negative exponent, now we can use our regular rules of minus signs. And this one reminds us that this is actually minus 4 times minus 4 when we square it. The minus sign goes along for the ride, or it's included in the quantity. That's another way of saying it. And so this simplifies to 1 over 16. But it's really critical that you understand the difference between generic run-of-the-mill minus signs and negative exponents, which really symbolize something quite different than a minus sign. It's a shame they look exactly the same because that's confusing. But these really are a different beast altogether. That's all. And you have some good practice in these. C, D, E, and F are practicing this skill. So even though John didn't give us any examples, he is giving you lots of practice problems. So, yay. Okay, that's the end of 36. I'm gonna go Google who that guy is. It's John Krasinski is the actor's name, right? He was Jim in The Office, and he plays this nerdy superhero guy, and it's not Bourne. I'll find out, and I'll tell you next time. Okay, bye. Or maybe you know, and you're just sitting there right now going, oh, she's not, I know, but she doesn't. It's okay. I know other things. Okay, bye.